Okay, kids, so that was knowledge that you needed to be able to work through some of this. So now we're going to talk about the method of simplifying rational expressions. You're going to factor both the numerator and the denominator fully. Look for all types of factoring, and always common factor first. Reduce any common factors in both the numerator and the denominator. We talked about that. And write any restrictions on the variable. Now that's what we spent a lot of time talking about in class today, restrictions. Recall that we cannot divide by 0, therefore we must ensure that any factors that are in the denominator throughout our solution are not equal to 0. 5 over 0 on a calculator equals error, and it's called undefined, and again in the last video we went over why that was. So let's take a look at this. You've got a function that's going to be y equals 5x over x plus 3. Now, notice, there's no y equals here, but you know that we can set it up as this equals that if I invent y. So there's just an idea. Now, what we're going to do is we're going to talk about all the values of x that can go in there. So all the x values that possibly can put into this equation. We have a formal word for that. That's called the domain. All these x values will go in and they'll come out. They come out as y values. That has a formal name and it's called range. You've done this in grade 9. In grade 9 you had your x values and you put them into y equals mx plus b and they came out as y values. We'll get rid of this, and that was your function. So maybe I make it 3x plus 2. So if I put in negative 1 into x, so it became negative 3 plus 2, so it also became negative 1. If I put in 0, 0 goes in for x, plus 2, we got 2. If I put in 2, 2 goes in for x, that becomes 6, that becomes 8, giving us the table of values that you would normally see, x, 3x plus 2, which is your y, okay, negative 1, 0, 2, negative 1, 2, 8, negative 1, negative 1, 0, 2, 2, 8. So that's a recap of grade 9. Notice that our function looks a little bit more interesting than your grade 9 function, but it's still the same idea. We're going to come up with x values that can go in and range values that can come out. Notice you got to choose any value of x that you wanted. Any single value of x that you wanted to choose, you could put in there. The same was true in grade 10 when you had this. You could put any values of x that you wanted to in here. So you pick negative 2, negative 1, 0, whatever you wanted. There was no restriction. There was no limit. There's that word, restriction. There was no x values you couldn't choose. Every single x value had a place on that. Now, if we think about this graphically, what that means is, let's say I draw a line, and this is y equals 3x plus 2. Every single x value along here, every single x value that I can have here has an associated y value to it. So you could choose any x value you want, put it in, and you get a y value. The same thing is happening here. Any single x value I put in has an associated y value to it. So we got to put in any value of x we wanted. But now we're in grade 11. Our function is a rational expression. It's a polynomial on top and on bottom. And we know mathematically you can never divide by 0. So we have to ensure that we never, ever, ever divide by 0 here. Why? Because then we don't have a y value that can come out. If ever I end up with a 0 in the bottom here, we have a problem. So that's the idea of restrictions. So our question was 5x over x plus 3. What x values can I not put in here that will give me a problem coming out? Well, the answer is if the bottom is 0. So if I was to put in negative 3, notice what would happen. It would be 5 times negative 3 over negative 3 plus 3, which would be negative 15 over 0. And that is kapow! No good, undefined. There's no associated y value that can come out. So we have to restrict the domain. Now, any other value could go in, even 0 itself. If I allowed x to be 0, it would be 5 times 0 over 0 plus 3, which will be 0 over 3. 0 over 3 is perfectly fine. It's just Mr. White's life. No friends. Let's put 3 of them together to go play pool. I have no friends. I can make no groups of 3. That's an answer. This is the x value. That's the y value. Not a problem. However, this, not so good. The kapowie is bad. It's undefined. All right, so what do? Well, when we look at restrictions, we say to ourselves, brackets are your friends, put brackets in. We say to ourselves, what value of x cannot come to this party? What can't I put in here because it's going to be undefined? So we say restrictions. We say that x plus 3 cannot equal 0. Therefore, x cannot equal negative 3. So we can put in any values of x that we want except this one. Why? Because it'll give us 0 on the bottom. Let's look at the next one. 7x squared plus x plus 3 over x. What are the restrictions? So you say, hey, I can put in any values of x except any values of x that'll make the bottom 0. Well, guess. X cannot equal 0. Because if it did, I'd get 0, 0, 3 over 0. Kapowie! Can't do that. Oh, you can't see what I'm writing. 0, 0, 3 over 0. Kapowie! And let's look at the last one. 3x plus 5 over x, x minus 2, 3x plus 4. Now we need to make sure that the bottom is never, ever, ever 0. Now there's 3 things being multiplied here. A, B, and C. A, B, and C are being multiplied. If any one of them is 0, then all of them will multiply out to give 0. That doesn't mean they all have to be 0. So for example, this could be 2 and this one could be 8. 0 times 2 times 8 is 0. Or this one could be 2, this one could be 0, this one could be 8. 2 times 0 times 8 is 0. Or this one could be 5, this one could be 9, and that one could be 0. 5 times 9 times 0 is 0. So if any of these are 0, the bottom goes to 0, and we get kapowie. So we say to ourselves, what values of x can we bring to this party? Which values of x can be part of this function? Well, x cannot equal 0, because if x equals 0, now think about this. If x equals 0, it'll be 0, 0 minus 2, and 3 times 0 plus 4. So you'll get 0, negative 2, 4. 0 times negative 2 times 4 is 0. The bottom's 0. Kapowie! X can't equal 0. Well, that guy can't be 0. He can't come to the party. Can't equal 2, because if it did, it would be 2, 2 minus 2, 3 times 2 plus 4, it would be 2, 0, 6, 7, 8, 10. 2 times 0 times 10 is 0. Kapowie! Can't do it. Even though these guys aren't 0, he is, and they're being multiplied. And last but not least, 3x plus 4 cannot equal 0. Take the 4 over. Take the 3 over. So you have restrictions that it cannot equal negative 4 over 3, 2, or 0. And you can see that again if you want. If I plug in the negative 4 over 3 into all of these, notice you get negative 4 over 3, negative 4 over 3 minus 2. And the only one that matters is 3, negative 4 over 3 plus 4. This is not 0. This is not 0, but take a look at this. Top times top, bottom times bottom. Negative 4 times 3 divided by 3. Reduce it. Negative 4 plus 4 is 0. So no matter what this is, times 0 gives you 0 on the bottom. And you guessed it, kapowie! All right, that's the end of that video, and I'll come back with the rest.